Hi guys, welcome once again to the OK Academy e-learning program. My name once again is Otin Joseph. I'm your facilitator for mathematics. Today we are going to have a lesson in grade 6 mathematics on the topic integers. Let's start the lesson. What are integers? Integers are whole numbers, including positive numbers, negative numbers, and zero. Whole numbers including positive numbers, negative numbers, and zero. What are whole numbers? If I talk of whole numbers, I'm talking of 1, 2, -1, -2, and so on. Not 1.5, 2/3. Those are fractions. I'm not talking of fractions. I'm talking of whole numbers. If we have a set and we put all the whole numbers inside, both negative and positive whole numbers, if we put all of them inside one set, then we are going to call the set of integers. Every whole number is an integer. No fraction is an integer. So one thing I want you to get in mind is that whenever we talk of integers, we are talking of the whole numbers, including positive, negative, and zero. This is how we represent the set of integers. We have -3, -2, -1, 0, 1, 2, 3, and so on. The ... here in front of the -3 means that we can count the negative numbers to -4, -5 to infinity. We will never end. This ... here behind the positive 3 here means that we can also count the positive numbers up to infinity. We can never end. Okay? So this is called the set of integers. Let's do a short exercise by identifying integers among a set of numbers. Okay? So let's identify the integers among this set of numbers. We have -26, -36, 36.3, 37, 37.1, and 26.6. Remember, we said integers are whole numbers. They are neither decimal fractions nor rational numbers. They are neither 0.1 nor 1/2. They are 1, 2, -3. They are whole numbers. So let's look at the numbers that qualify to be called integers here. So we underline them. -26 is a negative whole number. It qualifies to be an integer. So I underline it. -36 is a whole number, negative whole number. It qualifies to be an integer. I underline it. 36.3 is a decimal fraction. It is not an integer. 37 is a whole number, a positive whole number. It's an integer. 37.1 is not an integer. We cannot call it an integer because of the 0.1. So I don't underline it. 26.6 is also not an integer because it is a decimal fraction. Let's move on to number 2 and see if we can identify our integers. 33 is a whole number. It qualifies to be an integer, so I underline it. 33.2 is a decimal fraction. It can never be an integer. -4 is a negative whole number. It's an integer. Negative 43.5 is not an integer. It's a decimal fraction. 0.5. 0 is an integer. It is the bridge between positive and negative integers. Okay? Then 0.6 is not an integer. It's a decimal fraction. Let me add 2 over 3 here. Are we going to underline the 2 over 3 or we are going to leave it just like that? We are going to leave it just like that because it is a fraction. When we talk of integers, we talk of the numbers that are neither fractions. They are not fractions nor decimals. They are whole numbers. Okay? Good. I know by now you will be able to distinguish integers from non-integers. When you have a set of numbers all mixed up, you can select the integers from them. Okay? Let's move on. The next thing we are going to do is to locate integers on the number line. We usually represent integers on the number line. How do we locate them on the number line? Let's learn to locate our numbers on the number line, the integers on the number line. This is the number line. I know you're already familiar with it. The numbers are represented as points on the number line. You can see that each side of the number line has an arrow. It simply means that the numbers do not end. Okay? This does not mean that we have ended at 3. We can move on to infinity, okay? And on the left side too, we can move on to infinity. 0 is our reference point. It's going to be our reference number because it is the bridge between the positive and negative whole numbers. 0 is a bridge, so I take it as my reference point. Reference point simply means we are going to use it to do a lot of things over here with respect to the number line, okay? Now, let's look at something here. Every number on the right side is greater than the one on its left, okay? So all numbers to the right of 0 or to the right of others on the number line are greater, whilst all numbers to the left are smaller than those on their immediate rights. Okay? What do I mean by this? If I take 0, 1 is on the right of 0. So 1 is greater than 0. If I take 1, 2 is at the right of 1. So 2 is going to be greater than 1. If I take 3, there is 4 over here. 4 is greater than 3 because 4 is on the right of 3. Let me come to the negative side. If I take 0, negative 1 is on the left of 0, so 0 is bigger than negative 1. If I take negative 2, negative 1 is on the right of negative 2, so negative 1 is bigger than negative 2. Whilst negative 2 is smaller than negative 1. You don't need to confuse yourself. Okay, don't say that because this is 2, this is 1, this must be bigger. No. The rule says that any number on the right of another is bigger than that number. So negative 1 is on the right of negative 2. So negative 1 is going to be bigger than negative 2. Okay? Don't confuse yourself here. Let's come here. Negative 3 is on the left of negative 2. And every number on the left of another one is smaller than that number. So because 3 is on the left of negative 2, 3 is going to be smaller than negative 2, and negative 2 is going to be bigger than negative 3. Irrespective of this is 2, 3. Because of the negative signs and because negative 3 is on the left of negative 2, negative 2 is going to be bigger than negative 3. Okay, so I can say that negative 3 is less than negative 2 here, because negative 3 is on the left of negative 2. And here, I can say that 3 is greater than 2. 3 is greater than 2 because 3 is on the right of 2. Okay? 2 is less than 3 because 2 is on the left of 3. According to the rules that we are using here, okay? So that is how we locate our points or our integers on the number line. Now, we know what integers are. We are also capable of sorting out integers when a lot of numbers have been mixed up. We are capable of locating integers on the number line. We are capable of distinguishing between which one is greater and which one is smaller, as represented by the number line. The next thing on the lesson is to do some arithmetics with integers. We are going to learn how to add and subtract integers by using the number line. The number line. Let's say we have 3 and 5, and we are supposed to find the sum of 3 and 5. Whenever you want to find the sum or the difference of any two numbers using the number line, this is what you have to do. You have to start from the smaller number. You have to locate the smaller number, okay? So which one is the smaller number? 3. 3 is my smaller number, so I locate it on the number line. I locate it with a point on the number line. After locating the smaller number with a point on the number line, the next thing I'm going to do is to jump the number of times of the next number. Okay? A number of times as much as the larger number. So here, the next number is 5, which happens to be our larger number. I will stand at 3 and jump 5 times because the larger number is 5. Now, am I jumping to the left of 3 or to the right of 3? You will jump to the left of the number when the number you are talking about is negative. However, if it is positive, then you are supposed to jump to the right. Okay? So because 5 is positive, we are going to jump to the right of 3 5 times. So let's start. We stand at 3. We jump 1, 2, 3, 4, and 5. I started from 3 and I ended at 5 because 3 is a smaller number, 5 is a bigger number, so I counted 5 and I landed at 8. Counting from 3 5 times and landing at 8 simply means that the sum of 3 and I started from 3 and landed at 8. I jumped 5 times and I ended at 8. Starting from 3 and ending at 8 by jumping 5 times simply means that the sum of 3 and 5 is equal to 8. I started from 3, I ended at 8 by counting or jumping 5 times. And it simply means that 3 plus 5 is equal to 8 from the number line. Let's try another example. So let's call this example 1. Let's take example 2. For example 2, let's find the difference between 3 and 5. So we got 8 for this part. This time around, we have 3 minus 5, not 3 plus 5. So let's look at how we are going to get the answer to 3 minus 5 by following the same method as we did for 3 plus 5. Okay? Let's locate the smaller number first. We have 3 and we have minus 5. You have to take note that whenever you have an operational sign, either minus or plus in front of a number, because it is in front of the number, it forms part of the number. Okay? Minus here is in front of 5, so it forms part of 5. So we are having minus 5 or negative 5. We have negative 5 and 3. By the rules I listed, negative 5 is on the left of 3. Therefore, it is going to be the smaller number. We know that on the number line, a number on the left of another one is the smallest. Okay? So since negative 5 is on the left of 3, negative 5 is going to be the smaller number. So I will step at negative 5. So I have stepped over there. I'm going to jump. Now, am I jumping to the left or to the right of negative 5? We come to the bigger number. That one will tell us. 3 is the bigger number and it is positive. Once the bigger number is positive, we have to jump to the right. If it were to be negative, then we would be jumping to the left. Okay? So because it is positive, we have to jump to the right. Let's start jumping. We are going to jump 3 times. So we start from negative 5, then we jump 1, 2, 3. There we are. We landed at negative 2. This simply implies that 3 minus 5 is equal to negative 2. Let's take 2 more examples. 2 more examples. Be involved, okay? Whatever I am doing, make sure you take your notepad and practice it alongside with me. That will aid your speedy understanding of the concept of integers and their arithmetics, okay? Now, let's move on with another example. Right now, we are having negative 3 plus 5. So we are having the sum of a negative number and a positive number, but this time around, negative 3 plus 5. The first thing to do is to draw your number line. So I am drawing my number line. Make sure you draw your own. There I go. I have my number line. The next thing to do is to locate the smaller number. Okay. I told you that any number to the left of the other is the smaller one. We are having negative 3 and we are having positive 5. Let's check on the number line the locations of negative 3 and positive 5. Okay? We have negative 3 here. We have positive 5 here. We can see that negative 3 is on the left of positive 5. Therefore, negative 3 is going to be our smaller number. I step at negative 3. The next thing I have to do is to jump 5 times. Why am I jumping 5 times? Because 5 has been discovered to be the bigger number between negative 3 and itself. Am I jumping to the left of negative 3 or to the right? 5 is positive, we can all see. Because 5 is positive, I am supposed to jump to the right of negative 3. 5 times. So let's start. Put your pencil at -3 and start with me. 1, 2, 3, 4, 5. We landed at 2. We started from -3, we counted 5 times to the right, and we have landed at 2. This illustration here simply implies that -3 plus 5 is equal to 2, as we have here. Okay? Alright. Now let's move on to the last example for this lesson. We have -3 plus -5. All of them are negative numbers. Don't worry. Are you bothering with how we are going to solve this one? We will solve it very soon, and you will get to understand how to deal with such situations. But the first thing to do is to draw your number line. So I draw my number line. So we locate the smaller number, and we have seen that -5 is on the left of -3. Therefore, it is the smaller number. The next thing to do is to step at the smaller number you have located here. Then you jump 3 times. Are we jumping to the left or to the right of -5? We can all see that 3 here is negative. And if the number is negative, you are supposed to jump to the left. Okay? So I am going to jump to the left of -5 3 times. Let's start. Put your pencil at -5 and let's all start moving. 1, 2, 3. Yes. I started from -5 and I have landed at -8. This simply implies that -3 plus -5 is equal to -8. -3 plus -5 is equal to -8. I believe with these 4 sets of examples, they are enough for you to get the understanding of the arithmetics of integers. However, you need not worry. If you still don't understand, you need to watch the video over and over again, taking your time to go through the examples with me. Okay? Before I leave, I am going to give you 3 trial questions you have to try at the comfort of your homes. Okay? So, these are the trial questions. These are the trial questions. So, these are the trial questions. Use the number line to solve the following. We have 5 plus 7, -7 plus 5, and -5 plus -7. If you are confused with how to solve these questions, play back the video, watch again and again. Go through all the examples step by step with me. After that, come and try these questions yourself. And you give a thumbs up to yourself after you have been able to understand the concept and have been able to solve the examples very well. This brings us to the end of today's lesson. My name once again is Otin Joseph. I'm your facilitator for mathematics on the OK e-learning program. You know that we are not in normal times. I will always tell you to stay at the comfort of your home and enjoy the lessons if you have nothing doing outside. However, if it is necessary for you to leave your home, always make sure you mask on. After masking on, move out with your hand sanitizer. So within every 15 minutes time, you will be rubbing your hands with alcohol-based hand sanitizer. Take good care of yourself till we meet again on another lesson. Goodbye.